In this video, I'll demonstrate some basic DateTime functions in PySpark. I've created a data frame containing fake data consisting of an employee name and their hire date. So the schema for both of these columns is to be a string. The reason for this is because the hire date value is not in the standard date format. The standard date format is 4-digit year hyphen 2-digit month hyphen 2-digit day, whereas this format is 2-digit day, 2-digit month, and 4-digit year. So let's perform some DateTime operations on this data frame. To start with, let's turn this hire date column into a proper date data type. And we can do this using the toDate function. So let's refer to the documentation. You can access the toDate function under DateTime functions like this. And then if you scroll, you can try to find it. Here it is, toDate. So let's click into it. So this function converts a string column into a date. The first parameter is the column. So these are the input column values. Then the second optional parameter is the format. So you need to specify the format if it's not in the standard date format. The standard date format, as I mentioned, would be 4-digit year hyphen 2-digit month hyphen 2-digit day. But if it's not in that format, then you do need to specify what the input format is so that PySpark understands how to convert the input string. You can see the DateTime patterns and how to reference them in this format argument here. So here is DateTime pattern. So if you click into it, you can see the symbols and the patterns. So a year would be a lowercase y. So if you wanted to represent 4-digit year, you would do 4 lowercase y's. Day is an uppercase D. So that's day of year, sorry. Day of month is a lowercase d. And then you've got the month of the year, which is an uppercase M. So now that we have this, we can do the date format. So let's use the toDate function. So first we need to import the function. So from PySpark.sql.functions import to_date. And then what we can do is df.with column hire date, and then we can use toDate on the hire date column. So this is the hire date column. And then we need to specify the format. So the input format is 2-digit day, 2-digit month, and 4-digit year. So that format matches this format here. So let's display that. So as you can see, that is indeed a date. So it's been converted. And as you can see, it's now in standard date format, 4-digit year hyphen 2-digit month hyphen 2-digit day. So let's actually fix this to the variable df, but instead we will do a df.display at the end. Great. So we have now reassigned this data frame to this variable df. So we have changed this to be a proper date column. Similar to the toDate function, the toTimestamp function takes the same parameters, except it outputs a timestamp. So I'll import the toTimestamp function, and then I will create a new column called hire timestamp. So I will do df.with column, and then I'll call it hire timestamp. And then I can use to_timestamp to convert the values in the hire date column. I don't actually need to specify the format string this time because this is in a proper date format. So PySpark will know how to output this as a date. And I can do .display to verify this. And that's worked. Well, the reason we needed to specify the format string in toDate was because the input date values were not in the standard date format. So we had to tell it what the format was. Whereas in this case, hire date was converted to the standard date format here. So let's reassign this to the variable df. And then let's do df.display. Great. So this is what our data frame now looks like. Now you can also convert a date or a timestamp to a string formatted to your liking. You do this with the date_format function. The first argument for this function is the column, and the second is the output format. So for example, let me create a new column called year_month that returns a string consisting of the 4-digit year, an underscore, and then the 2-digit month. And then you can specify either a date or a timestamp column. So let me do df.with column. The column will be called year_month. And I will use date format, but just let's import it first, otherwise we'll get an error. So in the parenthesis, I will specify higher date. It could also be higher timestamp. It doesn't really matter as long as it's a date or a timestamp column. And then the format you'd like to output that in. So I would like it in 4-digit year underscore 2-digit month. So this is doing the opposite of toDate. While toDate takes a string and outputs it as a date, date format takes a date column or a timestamp column and outputs it as a string formatted to the way you specify. So let's do .display. So that's worked. You can format it however you like. You can even be more complicated with it. So for example, if I change this to 2-digit day, comma, and then if you see the DateTime patterns, if you want to output the full month name, you can just do 4 uppercase M's, like so. And then I want 4-digit year, like so. So as you can see, that is the format here. Okay, so now let me show you another function, curDate, which is short for current date. It returns the current date. And then another function called now returns the current timestamp. So let me import these functions. So I will import curDate and I will import now. So what I will do is df.with column, and I will create a new column called current date. And that will just be the result of curDate, open close parenthesis. And then I will do another with column, and I will return current timestamp. That will be the result of the now function. And you have to open and close parentheses for these functions. So let's display that. And as you can see, here's the current date, here is the current timestamp. So these are the values for me currently. Your values will of course be different because this just returns the current date in the system for me. You can get the difference in days between 2 date columns via the dateDiff function. It takes 2 columns. Both dates, it will return the number of days from the start to the end. The first column provided is the end column, and the second column is the start column. So let's create a column called days since hired, which will be the difference in days since the employee was hired. So to do that, we can do df.with column, and I'll call it days since hired, and that will be the result of date underscore or dateDiff, one word. You could do date underscore diff as well, but let's import it first. dateDiff. And then just to continue that, we have dateDiff, and that will be the difference between the now function, which is the first column. So now just returns the current day. So that will be the end. And then the start will be, let's say, the higher date column. And this will return it in days. So let's display it. So these are the days since hired. So it essentially does the difference between now, which is the current timestamp for me, and the higher date. So your values will of course be different because this is just the number of days as of the current date, which is the 4th of March, 2025. So if we want the difference in months, we can use months between instead of dateDiff. And it works exactly the same as it takes an end column date and a start column date. So let's import it. So I will do months underscore between. So now I can literally just copy this, change this to months since hired, and then change this to months between, and run this. So we now have the months since hired. Great. So that was a demonstration of some of the DateTime functions in PySpark. Please refer to this documentation, going to the Python API docs, API reference, and then Spark SQL functions, and then go to DateTime functions. This will contain all of the functions that I've described, along with additional functions that you can use when you have the specific use case for it.